Hello followers and viewers, welcome to my new channel. Today we will be considering second order boundary value problem. Second order boundary value problem is in standard form consists of all the second order linear differential equation. You can see this is a form of linear equation whereby we have a second order addition to what? To the p of xy prime plus q of xy is equal to this. And if this one is not equal to 0 or more than 0 is not equal to 0, we call it non-homogeneous. And if this one is equal to 0, what do we call it? We call it what? Homogeneous. And the boundary condition, alpha 1 y of a plus beta 1 y prime of a gives gamma 1. And another condition on it, alpha 2 y of b plus beta 2 y prime of b gives gamma 2, where p of x, q of x, and alpha and phi of x are continuous on a, b. When we talk about a continuous function, it means a function is said to be continuous if its limits exist and it is well defined. If it is continuous, it means it's a well defined. And alpha 1, alpha 2, beta 1 and beta 2, gamma 1 and gamma 2 are all a real constants. They are a real constant. When we talk about a real constant, it can be positive or negative number. Furthermore, it is assumed that alpha 1 and beta 1 are not both 0, and also that alpha 2 and beta 2 are not both 0. So, when we are talking about the value problem condition here, we are talking about that when we have an alpha, the real constant of alpha and beta 1, they can never be both 0. Either it is 1 or 0. And also, the real constant of alpha 2 and beta 2 is what? Is either positive or what? Neither positive or non-negative. That is, it can never be 0 as well. Alpha 1 can be 1 and beta 1 can be 0, but both of them cannot be 0. That means alpha 1 can never be 0 and beta 2 also can never be 0 at the same time. The boundary value problem is said to be homogeneous if both the differential equation and the boundary condition are homogeneous. That is, phi of s is equal to 0. This is a standard form of second homogeneous. That is, this is standard form of homogeneous. If this phi of x, this is a Greek letter, is a phi of s. If this is equal to 0, it means if all this is equivalent to 0, it means it is an homogeneous. So this is the condition we have been given, and y1 is equal to y2 is equal to 0. Otherwise, the problem is non-homogeneous. Is non-homogeneous. It means if phi of s is not equal to 0 and y1, y2 are not 0, they are what? It is non-homogeneous. So thus a homogeneous boundary value problem has the form y double prime plus p of xy prime plus k of xy is equal to 0. Alpha 1 y of a plus beta 1 y prime of a is equal to 0. Alpha 2 y of b plus beta 2 y prime of b is equal to 0. It means if you want to solve a second order boundary value problem, it must be in form of this, and if it is in form of this, that is the general form, it must be in general form of this, whereby you have a coefficient of y prime and coefficient of k of x, and it's a second order, and you must be able to identify alpha 1 y of a, alpha 2, that is, this is the boundary condition, while this is a general form of the second order homogeneous. The theorem: let y1 of x and y2 of x be two linearly independent solutions of y double prime plus p of xy prime plus k of xy is equal to 0. Non-trivial solution. When we talk about a non-trivial solution, a solution is not identically equal to 0. If you have a solution y1 is equal to y, you can say y1 is equal to y2 is equal to 0. We call this type of solution as a trivial solution. But if y1 and y2 is not equal to 0, we call it a non-trivial solution. So this statement, it means when a solution is not identically equal to 0 to the homogeneous boundary value problem, and the homogeneous boundary value problem exists if and only if the determinant of all this is equal to 0. It means for us to solve a boundary value problem, if you are able to y1 of y2, that is the general solution, is equal to 0, it means we have to test as well using this determinant to check if it's also equal to 0. That is, if it is equal to 0, it means it is not the general solution of y1 y2 give us 0. Determinant also exists that it also gives us 0. And if it is not equal to 0, it means the only solution that gives us is 0, that is trivial solution, is the general solution for the homogeneous part. So that is we are having alpha y1 of A plus beta y prime of A, then alpha 2y of B plus alpha 2 y2 of B. Alpha 1 y2 of A plus beta 1 y2 of A, alpha 2 y2 of B plus beta 2 y prime of 2. This is y prime 2 of A, y prime 2 of B is equal to 0. And we get all these three constants from the boundary condition given. So let us consider the next video on how to solve a second order homogeneous. Thanks for watching.